Good day, everyone. In today's class, we'll be looking at the topic angle of elevation and depression. This is a topic under what we know as trigonometry. And you're going to see a lot of questions in angles of elevation and depression in WAEC past questions and NECO past questions. It's not a difficult topic if you understand the basics. And I'll briefly give you the basics of angle of elevation and depression. If a man is standing on a horizontal ground, this man has a normal line of sight. If there's a building and this man attempts to look to the top of the building, you will discover that an angle will be formed between his normal line of sight and the new line of sight. This angle that is formed here is known as angle of elevation. On the other hand, if there's a mountain and there's someone standing here, this person standing on the mountain has a normal line of sight. If I have a sea that has a boat, and this man attempts to look down to the boat, he will have a new line of sight. An angle will be formed between his normal line of sight and the new line of sight. This angle here is called the angle of depression. This is the basic thing you need to know about angle of elevation and depression. We'll apply it in solving a question and then we'll see how we'll go from there. Elevation of the top of a tree. The angle of elevation of the top of a tree, 39 meters away from a point on the ground. 39 meters away from the point on the ground is 30 degrees. Find the height of a tree. Remember that with angle of elevation, you can calculate the height of an object and you can calculate the distance from a particular point of observation. Alright, let's attempt solving that question. The angle of elevation of the top of a tree, meaning there is a tree. I will represent this tree with a straight line. The tree is 39 meters away from a point on the ground. If this is the point on the ground, let me call this point P. If this is the point on the ground, and this is the distance between the point P and the tree. Remember that this is my tree. Now, the angle of elevation to the top of the tree is 30 degrees. And I have been asked to find the height of the tree. This is the height of the tree. Okay. Now, for me to find the height of the tree, remember that in the question we also told that the tree is 39 meters away, so I'm going to have 39 meters. I'm sure in your former classes, your previous classes, you were taught about SOHCAHTOA, where you have that, you have SOHCAHTOA, where you have that sine theta is opposite over hypotenuse, and you have that cos theta is adjacent over hypotenuse, and you have tan theta opposite over adjacent. In this diagram, which is a triangle, you discover that my opposite is the side facing the angle. So this is the opposite edge. Of course, the longest side is the hypotenuse. And then this side is my adjacent. So I have opposite, adjacent, and of course hypotenuse. And of course, you know that the 2 points of interest in this diagram is the opposite and the adjacent, which means we are going to use the tan. For me to solve that, I know that tan theta is opposite over adjacent. And I know what my theta is, the angle 30 degrees. So tan 30 degrees will give me my opposite, which is h, over my adjacent, which is 39. Alright, so I have, if I cross multiply, h would be 39 tan 30 degrees. 39 tan 30 degrees. And of course, my h would be, now when you were doing special angles in your previous classes, you will observe that 30 degrees is a special angle, and the value of 30 degrees is same as root 3 over 3. And then so I'm going to have 39 times root 3 over 3. If 3 goes here 1 and 3 divides 39, which is 13, I'm going to have that my h is 13 root 3. Look at the solution again, and if you have any question, please kindly put it in the comment section. Alright, we'll look at one more question. Let's see another question. This time around, something that has to do with angle of depression. Okay, take the question. The angle of depression of a point on the ground. The angle of depression of a point on the ground from the top of a building is 20.3 degrees. If the distance from the point to the foot of the building is 40 meters, calculate the height of the building. Calculate the height of the building. I'll take the question again. The angle of depression of a point on the ground from the top of a building is 20.3 degrees. If the distance from the point to the foot of the building is 40 meters, calculate the height of the building correct to 1 decimal place. Alright. So, I will use a straight line to identify the building. Now, if I use a straight line, it means there's a normal line of sight. And then this is my building, remember? And if the angle of depression of a point on the ground from the top of a building, so let me assume that this is the point on the ground. I will use P to indicate. Now, if someone looks down from here, it means that the angle of depression is 20.3 degrees. Alright. And then what it means is that the distance, this is the distance between the foot of the building and that point on the ground. And the distance from the point is 40 meters. Now, remember alternate angles. According to alternate angle theory, we know that alternate angles are equal. What it means is that if this place is 20.3, this place also is 20.3 degrees. Now, we're looking for the height. Again, I'll use h. You can use any alphabet. I'll use h to find. Now, according to SOHCAHTOA, you will discover that the point of interest is the opposite and the adjacent. Again, remember that this is the opposite, this is the adjacent, and this is the hypotenuse. Now, if I use tan theta, I know that tan theta is opposite over adjacent. And this time around, my theta is 20.3. If my theta is 20.3, my opposite is h, and then my adjacent is 40. If I cross multiply, I'm going to have h is equal to 40 times 20.3. And of course, if one uses his calculator, you will discover that 40 times 20.3 will be 14.8 meters. Okay. You go through the solution again, and if there's any question, feel free to let us know your question in the comment section. All right, let's look at the more complex question. I'll take it from a wide pass question. All right, then we will solve. Okay, a tree and a flagpole are on the same horizontal ground. A tree and a flagpole are on the same horizontal ground. A bird on top of the tree observes the top and bottom of the flagpole below it at angle of 45 degrees and 60 degrees respectively. If the tree is 10.65 meters high, calculate, correct to 3 significant figures, the height of the flagpole. All right. Remember that before you solve, you must put it in form of a diagram. They mentioned the tree and the flagpole, and they said that the bird is on top of the tree. Of course, common sense tells you that the tree is going to be taller than the flagpole. Now, if I use this to represent my tree, and I use this to represent my flagpole, this is the distance between the tree and the flagpole. Okay? Now, the angle of, this is the normal line of sight. The angle of depression to the top is this. And remember that they've given us the angle of depression, which is 45 degrees. So I have 45 degrees here. And then we also have the angle of depression to the bottom of the flagpole. This is the tree. This is the flagpole. All right. If that's the case, remember that the angle of depression here is 60 degrees. And what you are being asked to look for is the height of the flagpole. What other information were we given? We were told that the tree is 10.65 meters high. So the height of this tree is 10.65. So how do I solve a question like this? You discover that this is more complex than the first two examples we solved. If I must find the height of this flagpole, and since I already know the total height, once I'm able to get this height, I can subtract it from the height. Of course, if here is 10.65, it means that everything here is 10.65. Question is, how do I find this height? But then, before I can find that height, you remember that I should be able to find this distance. And by alternate angle, you know that if here is 60, this place is also 60. So I can find, let me call here x, and then we can solve for x. So I'm dealing with opposite and adjacent. So that's tan. So tan 60 would give me my opposite, which is 10.65, over adjacent, which is x. If I cross multiply, I would have x tan 60 equals 10.65. If I divide both sides by tan 60, I'll have that x is equal to 10.65 over tan 60, which will give me my x as 10.65 over tan 60. So I have 6.149. Okay, that is for this. If this is this place is 6.149, it means that here is also 6.149. I'm sure you're following. All right, remember our goal is to find this. So we should consider this small triangle. I'll use the black marker to mark it. If you consider this triangle right now, you will discover that we are dealing now with angle 45. So with this angle and this place, I can find this small space. How do I do that? I will still work with tan, opposite and adjacent. Opposite and adjacent. I'm working with a smaller triangle now. So this time around, I will have that tan 45 is equal to, let's call here y. Y over 6.149. Meaning that my y will be 6.149 tan 45. Everything would give me 6.149 tan 45 would give me 6.149, of course, because tan 45 is 1. Alright, so I have 6.149 for this area, for this length. Now, since I'm looking for this height, so I can now comfortably say that the height of the flagpole will be equal to 10.65 minus 6.149. 10.65 minus 6.149. And of course, that would give me 4.501. And remember that WAEC demanded that you must correct your answers to 3 significant figures, and you must take note of that. That would give me 4, so approximately I'll have 4.50. This is the 3 significant figures, and that's the answer. Alright, go through the solution again, and if you have any question, drop it at the comment section. Alright, I'll be leaving you with an assignment now, and I'll also be taking it from a WAEC past question. Okay, take the question. From an aeroplane in the air, and at a horizontal distance of 1050 meters, the angles of depression of the top and base of a control tower at an instance are 36 degrees and 41 degrees respectively. Calculate, correct to the nearest meter, the I, height of the control tower, II, shortest distance between the aeroplane and the base of the control tower. Alright.